So today we talk about the proof, and today also we will do questions that are word problems. You see word problems at the back, applications, some kind of radioactive question, and all those, the last questions, intersection of graphs and things like that. So those are the ones I want us to really focus on today, okay? All right, so let's quickly start. Alex, shoot. What question? Alex. What's going on? Can everybody hear me? Can Alex hear me?
Yes.
I can hear you.
Yes.
I'm talking to you, sir. You just went quiet.
Sorry, Wi-Fi problem. I can't hear you for a second.
Okay, no problem, no problemo. All right. Question what again?
Question 47, D.
Question 47D. Okay, so question 47D about we show ourselves what the question says. That's the question it's talking about. Show that log x base mn is the same as log x base n divided by 1 plus log m base n. Okay, no problem. Let's see. That should be easy. Has anyone done it? Yeah, okay. Let's see. Miss Joey said, yeah, I did it. Just cool. All right, so today is Friday. Friday will be this, right? Did I get that? You see, I'm learning. I'm good. I'm good. You gotta give that to me. Okay. I really want to go to Shanghai airport sometimes, and the immigration talk to me in English, and I reply them in Chinese. That would be so cool. I'm like, oh my God, he speaks Chinese now. Then they don't have to deport me because they're going to think I'm half Chinese, half African, right? Like, oh my God, yes, we can let him in now. And I can go to Kelly's house because she lives in Shanghai. All right, question 47. And I go to Malaysia someday too. So Joey, don't worry, I'm coming to say hello to you too. I've been to Hong Kong, so I asked for all your countries and I'm going to visit them. Log 47D, log x mn 1 plus log nm. What's the other one again? Log x base n. So to do this, so I say proof. That's like saying the answer is as follows, all right? When you're proving, you start from the left-hand side. But sometimes you start from the right. But in most questions, you always start from the left. So you say left-hand side equals log x mn. So you walk your left. Are you listening, everybody? You walk your left and continue until you get your right. Okay, everyone? So you don't do left, right in every line. Can everybody hear?
Mr.
Yes.
Yes. I think it's 1 plus log log m base n.
Oopsie. So it's the other way?
Yes, thank you.
Log m base n, like that? Okay. So if you look at this, what base has this changed to, Alex? From your left-hand side, if you look at your right, what base is the answer going to? From the question to the, just look at the board, it's on the board. if you look at where your base at the beginning is mn. So, but there's a change towards base. If you look at the right hand side,
base n.
Base n. So that's your goal. Change to base n. So just apply change of base. If you are changing to base n, it's going to be log base n log base n. And at the numerator, we have this. Denominator, we have this. Isn't that the change of base principle? Does everybody get this? Please, I need a response more than copying from. All right, so this will be mn.
Yes.
Okay, so if you look at it, the top number looks good. So we only need to deal with the second number. So you have that. This, if you have products, it must have been the addition of two logs. Is that not? Okay, so this must have been log to base n of m added with log to base n of n. Isn't that what will have given you mn?
Yeah.
Okay, so what is this? You apply another principle about logarithm of the number to the same base is 1, right? So this is this plus 1. Can you see that, Alex? So all I need to do is just rewrite it by putting 1 first. And I have that here. Then you can say which is equal to right hand side, and that's the end of the proof. So your proof will start from the left and get to the right. You are not supposed to write left this all the time. Okay? You're supposed to pick one side and simplify, simplify, simplify until you achieve the second one. That's how proof is done. If that is not the way you have done any of the proofs, then you haven't really worked out the details properly. Okay? Any other question quickly? 10 minutes for these questions.
For me, 47C.
47C. That's from Miss Malaysia. Miss Joey Malaysia. I heard it's a beautiful place. I want to visit Malaysia. 47C. All right. Oh, that guy. 47C is, Joey, you want to call the question, please, so I don't have to open to the Windows brackets?
Bracket log base A, AB, and another bracket log AB base B is equal to log AB base A plus log AB base B.
Isn't that weird? Like the product of two log is giving us their sum because they are AB, AB. That's weird, right? Okay, let's see. So again, start from one and get the other. Let's check this out. So we're gonna say left hand side. We can start from left. I always start from the left, unless when the situation is so difficult, I start from the right. From the left, we have open brackets, log AB to base A, then another log AB to base B. What can anybody suggest we do first? Alex?
Turn it into fraction.
Okay.
Yeah. We change the base.
Change the base. Now, okay, if you change the base, I don't think so. If you change the base to base what? Okay, let's see, let's hear that. Change the base to base what?
Log ABA times 1 over log ABA times 1 over log ABB.
So something like 1 over log ABA. This is
no log A to the base of AB.
okay, log A to the base of AB times 1 over log this again, like that?
Yes.
Okay, so how does this help?
And then it equals to 1 over log A. Log 1 over log A to the base of AB times log B to the base of AB.
1 over log A to the base of AB times like this.
Yes.
But
One.
that's this. Yes. How does that help us?
Then I will try to get the right-hand side as this fraction as well.
Simplify the right-hand side to also look like this.
Yes, and I can prove that they're the same.
No. Remember what I told you, start from one of them and make sure you get the other one. Not start from one of them, get somewhere, then make sure the other one meets you halfway. No.
Then I can do the reverse way, which is like 1 is equals to log AB at the beginning.
1 is equal to what? This one?
It's like I can do the reverse, which is like based on what I said just now, and then 1 is equals to 1 over log A base AB times log B base AB.
Yes,
and then the 1 can be converted to log AB to the base of AB.
Okay, I'm still trying to see how that will help. Can I have another suggestion? Anyone else? Nice try, Alex. Nice try. Look at what we did here, everyone. Can you see this? Can we do that here? Talk to me, guys. Can we do that here? Is it possible to apply this? Justin?
I didn't do it that way though.
Oh, okay. Let's hear what you did.
So the end answer, like the way I showed them that they're the same, is like also kind of like meeting halfway.
Oh, okay, so we don't want to use the halfway thing. I want to use from left to right. Okay, so because usually when someone says left-hand side is equal to right-hand side, you're not supposed to say this is left, this is right. Okay, you meet here, you meet here. So because they can meet here, so it means they are the same. We don't usually do proofs like that. We want to move until we get to this point. That's how we do mathematical proofs. Okay, only in some cases that you want to adopt that technique. All right, so let's see this. Let's split this into sum of two logarithms. So you agree this will be log AA, log BA, right? And this will be log AB, then log BB. All right, so this will be log, no, that's 1. Can you see that? That's 1. I hope I have everyone's attention, except Alex, who is busy doing his thing for whatever he thinks, however he thinks that makes sense to be doing that now. Can you see this? What do you suggest, Joey, to do next?
I am not sure.
Just try. You have 2 brackets, A plus B, C plus D. What is the first reasonable thing to do?
Expand it?
Expand it. Don't think too much. Expand it. Even if it doesn't make sense, if that is the only thing you can do, just do it. So 1 is going to multiply this, then 1 will multiply 1. So you have log A base B plus 1. That's 1 times this 2, right? Then this will multiply this. So I have log B base A multiplying log A base B. Then this times 1 again, log B base A, right? What do you think we should do next? Anyone? Come on. Anyone? Anson, Kelly, Melody, Candy. Come on. This is log B A, you can simplify this first. This can be simplified because they look like they swap positions. Right?
Oh, they equals to 1 time
That
together.
equals to 1. Isn't that one of the proofs? That's 47A. Can you see 47A? Right? So that's 1. So if you have done 47A, you just put 1 here. If this is an exam question, when you get to this point, you just put 1. Then in bracket, you said using 47A. You don't have to show it. But because I haven't shown 47A, so I'm going to put the 47A solution here. So, and that will be log B to base 10, log A to base 10, then log A to base 10, log B to base 10. Can you see that? And that's how this is 1. So this is 1, this is 1, and I need this, right? Okay, so this is log B, so I'm going to make this also log base B. While this part is 1. Understood? And this is log A. Okay, maybe I write this first, the way it was, so that I do not confuse you. Understood? So this and this, I will group them together. This and this, I group them together because I need just 2 logs. So log A base B, log B base B. This will belong to this. Can you see the solution already?
Yes.
So that's the last one is log base A. So from here, these 2 combine to give what? Log
AB base
B base B, and this one again?
AB log AB
base
base
A.
A.
So I just rearrange it because the base A starts first. So I just rearrange that. Log AB base A plus log AB base B, and that is equal to what? What's the last
Right-hand side?
Right-hand side. That's how to prove. Okay? Any other question? So here you may use 47A, state 47A if you have done it. So if this was some exam question, A, B, C, D, they are all in the same paper. If you have done A, you don't need to do all this again. Just jump from here and just call it 1 because you would have done this as 1.
How do you state 47A?
So if you want to do that, for example, you just say, in your question, you've done 47A, right? You've proved it, you got 1. So when you get to 47C at that point, and you have this, so the next line will just be 1. Then in brackets of that line, you write using 47A. Justin, understood what I said?
Yep.
So that's all you have to say, using 47A, which means, oh, I've done that, so I'm just using the proof that I've already done in the past. And we can see that from above that you have done it, so that's okay. That's how higher math is done. So you don't have to prove it twice. That's the point. Any other question quickly, please? I assume that's all. Okay.
Mr. Daniel, I have one more question that I'm not sure. It's question 44.
Question 44. Some of you are being quiet because you think someone is going to ask the question for you. Trust me, darling, maybe not. You better speak up. Thank you, Sonia. So question 44, the one with lean bracketing, right? Sonia. Is 44 the question with lean and a big bracket?
Yes.
All right. Just checking to be sure that is the question she's talking about. All right, let's do that. 44. Has anyone done 44?
Yes.
Okay.
Yes.
So let's do 44 for Sesonia. So in 44, you want to show that, should I play this one? Yeah. So we want to show that natural log, that's logarithm to base e, we call it natural logarithm of open brackets 1/16 times cube root of e is equal to minus 4 ln 2 plus no minus 1/3. So again, we start from left-hand side. Justin, what did you do first? Left-hand side is ln of Justin, what did you do first?
I changed 16 to the power to 2 to the power of 4, and then I changed cube root of e to the power of 1/3.
Very good. So that's the first thing. So this will be, I need Sonia to be attentive to what everyone is talking about. So this is 2 to the power of 4. And this is e to the power of 1/3. Justin, what did you do next?
I took I took away the I put to the power of -1, the whole thing, and then
Negative
remove
on everything.
Yeah.
So you mean what do you do in bracket now?
2 to the power of 4 times e to the power of 1/3 to the power of -1. Yeah.
Good. What do you do next?
Actually, at this point, I made the powers negative.
Yeah, you're right.
Okay.
So 2 to the power minus 4 and e to the power minus 1/3, right?
Yeah.
That's correct. You're right. Don't be scared. Good.
Yeah, I was pretty scared of that.
Because in indices, remember, if you have 2 times 3, maybe I give you 4 times 3. No, that's too much. Let's take 2, so it's easier. And you have to power 2. If you do the bracket first, you get 6 squared, which is 36, right? It's the same as give them the powers, 2 squared times 3 squared, which is 4 times 9, which is also 36.
Oh.
So in indices, when you have a, b to power n, it's a to power n, b to power n. So you're right. Okay? So
Okay.
don't be scared, Mr. Justin. All right, let's go. What do you do next?
I separated them.
Separate them, good. So ln 2 minus 4 plus ln e raised to power that. Yes, what do you do next?
Yeah, and then I move the -4 to the front.
Wonderful. This is plus minus, so you just write minus. You don't have to waste time. And this is one of them, right? Minus 4 ln 2. You can see that already. So how do I do with this one?
And that's log e, so it's just 1.
So that's 1. Remember, that's times 1. Since ln e means log e, which is 1. So that's it. Thank you, Justin. So ln 2 minus 1/3, and that is right hand side. This is using law 1. Okay, and we wrote this one because AB to power n is AN to power BA, AN, BN. That's the reason for this one, from here to here. That's the reason. Thank you. So Sonia, understood now?
Yes, thank you.
Good. All right. Everyone is good? Okay. So let's look at those word problems. By the time I do one or two for you, anyone want their remaining? I can, send you the picture so it doesn't look like I'm not sharing with you. Anyone want? Okay, so 5 minutes, all right, 5 minutes. I want you to, this is intersection of the Candice chiming, maybe with the second device. Okay, so let's see. Those kind of questions are in 57. Look at 57, everybody. So look at 57A, easy stuff. 57B, 57C. 57C is definitely quadratic. Same with 57E and F. Choose 2 questions. Let's do them together quickly. Choose 2 questions from 57. Kelly, choose one for us. Hey, Kelly. Is your screen frozen or you put a picture there so it looks like you are listening to me?
Sorry, I'm still opening it.
Okay. Yanko, please look at 57 also.
Okay, I'll choose 57F.
57F, okay. Are you sure? Everybody agree with that? Rita, I don't see your face because everywhere is dark. Okay, that's much better. Hello, Rita. Yeah, 57F, okay. Anyone else want to pick another one? With 57F, you can actually do 57C, so you'll see that very soon. And for 57E, I'll give you a clue. Can we choose one more question? Either B or D?
B.
B. Okay, did you say B or D?
B for boy.
B for boy. Okay, good. Okay, so 57B, that's actually easy, but that's fine. You want me to do the easy one? I'll do that. So 57B, then 57F. After that, I will take one of the word problems. I will take, I love to do 58. Then one of the population question, maybe 63 or maybe 62. 4 questions. I may take maybe 10 minutes extra, sorry. So let's quickly do this. So because after this, the rest is just your practice, your practice. Some questions in that paper, how do I say, are still beyond what you can do now because of sequences and stuff. So, but try as much as you can for now. So logarithm. So 57B. Can somebody give me the question? Melody, quickly. 57B question is what?
The question is 2 to the power of x. Wait, yeah, 2 to the power of x times 5 to the power of x minus 1 equals 0.01.
Okay, great. So what I will do is get rid of this minus. Everybody pay attention. 2 to the power of x. This means 5 to the power of x divided by 5 to the power of 1. Understood? Agree? Okay. Actually, 0.01 is 1/100. So this is 2 to the power of x times 5 to the power of x divided by 5, 1 over 10 squared. This is going to be 2 times 5 to the power of x. Am I right? Can you see the magic we're performing here? Can you see? Then we can cross multiply. Then we have 10 to the power of x plus 2 equals 5. Can you see? Your goal is to have one index on one side, one index on the other side. Okay, if you're able to do that, you take the logarithm of both sides to base 10. Any base, but base 10 calculator is easier. So I take log of both sides. If I do not specify the base, I'm talking about base 10 by default. So which means I have 10 to the power of x plus 2, I have equal sign, and I have 5. So what I mean by take the log of both sides is hard log and hard log. That's what I mean. Can you see? You can only do this if you take one side as one value. Why is Anika looking like that? Okay, so if you have it as a bracket, of course, the log affects the entire bracket. That's allowed. Okay, all right, so with this, I can apply the law of log. Can everybody see this? Yeah? Log 10 is 1, so that's gone. X plus 2 times 1 is x plus 2, and this is log 5. So x is going to be log 5 minus 2. If you have to leave it in exact form, you stop here. If you have to leave it in decimal form, what is log 5? That'll be log 10 minus log 2, 1 minus 0.3, that's 0.69 something. Can you check? 3010, that'll be 69.
6989.
98 what?
6989, so 699.
It's 9 what?
6989700.
So this is not 9 as well. So let's just say 699. So 3 decimal places. So that would be x. Can you see that? Okay. So let's take the other one. I'll send you this picture, so we don't want to waste time writing now. Okay.
Mr.
Hey,
Daniel,
Mr.
didn't you?
Daniel, I
Yes.
think that answer was just log 5 and not log 5 minus 2.
Are you sure? But this
You
2.
did a -2 because you only did log 5.
Ah, my bad, my bad, my bad. Thank you. So everyone is not drunk in math like me. So that's negative 1.301,
301.
something like that. Thank you. Good boys and good girls. 47, is that 47 or 57? 57, 57D now. Oh no, 57F. That's what Yanko said. 57F, e to power x, e to power minus x equals 3. Is that? Yeah. So what you do here, what is the first thing that comes to your mind is, this is negative, right? What do you want to do to it because it's negative?
1 over
1 over, thank you. That's why I said at this point, it looks like question 57C. Can you see? Because 57C has 1 at the top and 1 as denominator, right? We've talked about when you have 1 at the top, 1 at denominator. What do I say you do? Quickly, please. When you have something.
Oh, you let e to the power of x be a or any other letter.
Introduce a variable. Let e to the power of x be a. Once you do that, everything becomes a plus 1 over a equals 3. Then you multiply through by a. So that's a squared plus 1 equals 3a. Right? And that is a squared minus 3a plus 1 equals 0. There's no factor of 1 that gives 3. So what do? We can factorize. What do we do?
Use the quadratic formula.
Yeah, use the quadratic formula. So by quadratic formula, a will be, remember, minus b plus or minus, right? Unfortunately, a is the stuff, and maybe I change the variable. I don't want to call it x2. Okay, I'm just going to state it without stating the formula. So minus b would be minus 3 plus or minus root b squared minus 3 squared. 4ac is 411 divided by 2a, that's 2 times 1. Does everybody get this? So that's 3 plus or minus 9 minus 4. That's 3 plus or minus root 5. Understood?
Yeah.
Talk to me, please. Okay, good. So my possible values are a equals, I'm trying to wait till last minute before I introduce calculator values, because I don't want to introduce it here and approximate, then I approximate again. And I say recall. Okay, we want to recall. E to power x equals a. If e to power x equals a, I can say ln ex equals ln a. Why am I not using log this time? Why am I using ln? Can anybody tell me why I'm using ln? Unlike this one, when I got here, I applied log. I didn't do ln. But here, I'm using ln and not log. Anyone?
Because there's already an e there.
Because already in E, so you want to make sure you use something better, right? Are you just copying from the board, Melody and Denise and everybody else, or you are actually paying attention? Okay, so because it's already base E, so it's better you use logarithm to base E. So x ln E is equal to ln A. Okay, I did this first, so that's x times 1 equals ln A, right? So basically, x is equal to ln A. I'm doing this calculation first, so I don't have to do it twice in each case. Does that make sense? So now that I've established this, for each value, so x will be ln of 3 plus root 5 over 2, or x is ln of 3 minus root 5 over 2. Can you see that? Okay.
Yeah.
So imagine if you put e raised to power x equals this, or e raised to power x equals that, then you have to do this calculation twice. Okay? So that's why I did it first for a general A, then I can just substitute. So now you can use your calculator. If the answer is requested in the exact form, you stop here. If the answer is expected in calculator form, can somebody do it and give me the answer in 3 significant figures? The first one and the second one.
For positive is 0.96.
0 points. I said 3 significant figures, please.
962.
And the second one?
Negative 0.962.
Negative 0.962. Confirm, please. And that makes sense. Can anybody tell me why it is easy to see that these two values are correct? Can you see why it is easy to why we can say, yeah, it is correct? Can you see why? Look at the board.
Because
Yes, Kelly.
despite the sign, they are the same.
By what? Say that again.
So like if you don't look at the sign, one is positive, one is negative. The others are the same.
Look at it from here. Can you see the board, everybody?
Yeah.
This. That's why it's easy to know. Is Kelly paying attention? Because I can see you talking to someone else. Look at this. So when x is this, 0 point that, you get e raised to power that value, then e raised to power minus that value. When x is the negative, this negative comes first, all right? The minus that value is positive of that value. Do you understand what I mean now? Hello? Is everybody
Yes.
Yes.
So that's how I will know immediately that you are right. Another way to check this is this. Everybody, if you can quickly go to your decimals calculator page, I'll share my screen with you. E to the power x plus e to the power minus x minus 3. You plot that graph. Do you know why I did minus 3? Because I want to make it equal to 0. Hello, do you understand what I did?
Yeah.
So you make it equal to 0 so that the other part is y equals 0, which is the x-axis. And look at the point of intersection. Can you see it's a mirror? Okay, it's symmetric about that point, about 0. Can you see that? So look at this coordinate, 962 and 962. Can we all see that?
Yes.
Yes.
So that's that. We can actually check the first one too. You can check the first one as well, if you want. So in that case, just plot this times this, then minus 0.01. Shall we check that? 2 to the power x to the power x times 5 to the power x minus 1. No. Okay, I have to use brackets. Then minus 0.01. So that's the other graph. Now, we want to see where it crosses the x-axis. And we claim that it crosses the x-axis where? What was the answer we got?
Negative 1.305. 301.
Two values. Did anyone answer or two answers? One. Negative what again?
1.301.
So can you see where it's hard to see that point exactly, but you can see where it crosses, right? Understood, guys?
Yes.
It crosses somewhere here. So that's why you got the 1.3 something. So it's somewhere, it's very difficult to see that, but we can see it, isn't it? Hello, talk to me, please. So it's somewhere, this is the point. You see, it's not letting me choose orders. It's just giving me that particular point. Can you see? I'm trying to click other point, but the dot stays here. That's the point, minus 1.301. Okay? So that's how to check. You can put it graphically. Okay, I'll spend my extra 10 minutes. Okay, now look at, can you tell me, look at 58, everybody. I'm just going to explain this verbally. Look at 58, it's on the board. Two curves C1 and C2 are defined for all x. I hope you're paying attention, please, it's on the board. And have respective equations, y1 and y2. Show that the x coordinate of the point of intersection is given by this. What do you do? Hello, what do you do, please?
put like y1 equals y2 and then.
That's all. That's all. Put y1 equals y2. When you put y1 equals y2, you solve the equation because it's going to look like number 1. It's going to look like this. Okay? You put y1 equals y2. So put y1 equals y2, like she said. Now, what's the equation for y1 quickly? Somebody give me that quickly. Come on, come on, come on. What's y1?
Y1
A to
is
the power of
a to the power of x.
And y2?
2 times 3 to the power of x.
How do you suggest you solve this? Just take the log. You don't have to do some crazy stuff. You don't have to try to do any calculation. Don't try to do all the stuff that I did here. You don't have to. You can actually do what I did here directly without simplifying to this point. Okay? Just take the log. You take the log straight away. Log 8x. Now, that question is in the form of what? Can you see 2 log 3, right? Can you see this? Look at the solution. It's in form of base what? Everybody? Base what?
Which one are you talking about?
Question. The answer is in the form of what base?
2.
Base 2. Can everybody see what Justin is talking about? Here, it's on the board. Can you see? Did you see that, everyone?
Yes.
Yes.
That's your ins. That tells you what you need to do. So in that case, this will be base 2. So when you're applying any log, you apply log to base 2. So initially you have, sorry for taking this extra time, you have this, right? And you have 2 times 3 to base x. So you're going to apply log to both of them. So this will be log to base 2. This is also log to base 2. Did you see that? So this is going to be x log 8 base 2. This is going to be, because this is products, you can split them with 2 additions. Can you see that? So this is going to be, when you simplify this, you get 3. You have to show the steps. Why this is x log that. So you bring this together. X times 3 will be 3x. Then this is minus x log, and this is 1. You factorize. 3 minus, am I right? Did I write something wrong? No? Okay. So is equal to 1. Then x is equal to 1 over 3 minus that. Is that the answer we asked to show?
Yes.
Yes.
Yes. So that's how you do it. So I'm going to ask you to do 59, 60, and one of the population word problems. I give you 2 of the population word problems. They are just applications of what you have done. Okay, they are just applications. So I will tell you which one to do. And with that, we will say goodbye to logarithm as far as this level, this grade level is concerned. When you get to Form 5 and you have been taught sequences, then others like this question, like this 42 will make more sense to you. Like 41 will make more sense to you. Like 39 will make more sense to you. But right now, you don't need to worry about them. So I'll tell you which one to do. I'll send you the pictures of the board, and that will be it. So you write this properly in your notebook when I send you the pictures. Okay, please don't forget, you can, if you take log of both sides and there is more than one thing, you have to put it in brackets. So if I'm going to do this in the case, in the other one, I will do this. Okay, it has to be in a bracket, something like that, then log blah, blah, blah. Okay, then don't forget, you can split this into 2, then you can factorize x out, just like we did here. Okay, and that's how you do it. I'll see you next time. I have to go to my next lesson now. Bye.
Bye.
Bye-bye.